Yeah, thanks on everyone. Let's start off. Hope everyone went through the notes. The last thing we did was the potential and field due to point charges. Perfect. Next thing. Electric field and potential. Due to continuous charge distributions. So these are the results and questions also. So the first thing we will take, right, is a finite rod. You need to mug up these results, right? So let's say we have a rod here, lambda. Length of the rod is L. And there's a point P here at a distance D. Lambda is charge per unit length. It's called as linear charge density. Now remember, the formula for field is KQ by R square, but it is defined for point charges. So if I give you something like this, how do we find the electric field and potential at point P? Try, I'll give you a minute. So we have a rod of length L where lambda is a charge per unit length. So the charge is spread over the entire rod. So at a distance P from one corner, there's a point P. Find the electric field and the potential at point P. Try, give it a try. How do you approach this? Others hands on. Lambda by L epsilon. Can't do that, right? God. See, let me help you with one. So this is the point P, no? This is how we start. Let's say at a distance x from here to here, take a small piece. Understand that formula is valid only for point charges. So you're taking dx to be so small, you can assume it to be a point charge. So charge on this dq will be lambda into dx. So the small electric field due to this small charge will be k dq, distance is x square, direction is I cap. So this will be k, dq will be lambda dx by x square. Integral, this will give you the full field due to the rod. K lambda, what will be the limits? Can someone tell me what will be the limits? X is going from where to where? This is the first time you're meeting the rod now. What is x here? D. X is 0 here. What is this x? L plus D, no? Are you getting it? X is the distance from the point P to a small charge on the rod. I hope you're getting the meaning of that. So limits will go from where to where?
D to L plus
to L plus D. dx by x square का integration. So that is k lambda minus 1 by x limits g to L plus D. Substitute karo, you end up with k lambda L by D into L plus D. Check. That is the field. Potential का भी same logic है. K potential formula is k dq by x, kq by r. There is no direction. So this will be k lambda dx by x. So the potential, this is small potential. The potential will be k lambda integral dx by x. Limits will go from d to L plus d. So dx by x is ln x. Limits are from d to L plus d. You'll get ln a minus ln b is ln a by b. So ln L plus d by d. Check. Just a thing here, don't use center of mass concept here. Since field is proportional to 1 by r square, V is proportional to 1 by r. Center of mass works only for linear functions. Linear function also r power 1. Because some people did this thing last time. They said, okay, full charge is there. I will take the total charge in the center and then find the field. Doesn't work. Blunder. Remember we did a question with that hemisphere ka thing? Usme force is equal to EQ, right? So did you say it is proportional to power 1? E is constant, no? Yahan pe, this force was constant. That's why it worked. But here the field will change with the distance. So just be careful with that. Don't use center of mass concept when the functions are 1 by r square. Whenever the functions are linear, you can use center of mass. Check this out. Clear? Now, next one. This is an important result. You should definitely mark up this result. Previous one is still fine. Finite rod. So we have a finite rod, lambda. This is theta 1. This is theta 2, and this distance is d. Find the electric field at point P. Right? Let me show you how to do this thing. This thing involves it's like a derivation. Listen carefully how to choose elements. This will again, same formula will come in gravitation. So basically gravitation may the only difference, what? K ka place mein capital G will come, lambda will be lambda, L will be L. Everything will be same. Wherever there is K, replace with G. Wherever there is Q, replace with M. Questions are exactly same. See how to integrate this. At a distance x from this point, take a small piece dx. So the charge dq will be lambda into dx. So this small piece will give a field this way, dE. Let this angle be alpha. Let this be alpha. So dE ka value will be k dq by r square. R is this distance, d is this distance. So the vector at point P, remember whenever you integrate a vector, first you have to divide them into I caps and j caps. So this will be dE, vectors will be cos alpha I cap minus sin alpha j cap. So that's the first thing. Whenever you integrate a vector, always divide them into I cap, j cap, and then integrate. So field at point P will be integral k dq will be lambda dx by r square cos alpha I cap minus sin alpha j cap. Now From here we know tan alpha is equal to x by d. Differentiate on both sides. D tan ka differential is secant square alpha. This will be dx. We also know cos alpha is equal to d by small r. So r is equal to d sec alpha. Substitute everything here. K lambda integral dx will be d secant square alpha. R will be d square secant square alpha. D alpha होगा ये. D alpha. This will be cos alpha I cap minus sin alpha j cap. Secant square cancel off. Like you actually get a good integration. K lambda by d integral cos alpha d alpha I cap minus sin alpha d alpha j cap. What will be the limits? Angle is changing from where to where? If you look at this angle is going down and this angle is going up. So limits will be minus theta 2 to plus theta 1, minus theta 2 plus theta 1. Because you're going down is minus theta 2, going up is plus theta 1. Cos alpha sin alpha ka integration is easy. Please have a look at till here any step you didn't get. Like I said, the result is more important than the derivation.
Sir, sir, we can do minus theta to 0, then double it. Can be.
क्या?
इंटीग्रेशन में जब लिमिट्स लगा रहे तो माइनस थीटा टू 0 लगा के डबल कर देना चलेगा.
तो you mean to say theta 1 theta 2 दोनों equal है?
सर इन्फिनिटी जा रहा है ना तो
कहाँ पे जा रहे हैं infinity?
अच्छा फाइनाइट.
Please have a look at the steps I did. Any steps you didn't get, please ask. Then if I integrate this, the final result will be k lambda by d sin theta 1 plus sin theta 2 I cap plus cos theta 1 minus cos theta 2 j cap. This will be the formula for this, but there's a better way to remember this. I don't want you to remember like this. This will become confusing. So how you remember now? Along the bisector, meaning along the perpendicular component to the rod is k lambda by d sin theta 1 plus sin theta 2. Remember that way. Don't remember I cap j cap, because what will you do if the rod is at an angle? It will be confusing. So perpendicular to the rod, second component k lambda by d cos theta 1 minus cos theta 2. This is in the direction of theta 1. This is one way people get confused. They don't understand which way should I take. You know, it is parallel to the rod, but they don't know whether should I take it up or down. So we take this in the direction of theta 1, meaning you can choose any angle as theta 1. The signs will take care of it. This should be in the direction of theta 1. This is perpendicular to the rod. Please note it down. Put this down. We'll be doing problems based on this. Formula is important. You need to mark it up. Direct questions will come. This will again encounter in gravitation. We will see something similar in magnetism also.
Means not dependent on distance from P.
I can't hear you. Copy. Shaurya, if you can clearly see there now, you will see. Or you are just blind, you don't want to see. What are you asking? ये क्या था? The D is the distance, perpendicular distance from the rod. Clear? Let's see some questions on this. Now, before that, some more results of this. Case 1, if theta 1 is theta 2 is equal to 90, what you get is an infinite rod. So the result will be 2 times k lambda by d. And how will the field lines look for an infinite rod? For an infinite rod, if you're trying to draw the field lines, they look like this. Radially, they'll go in every direction. They'll be going out like spikes. Case 2, if theta 1 is 90 and theta 2 is 0, we get a semi-infinite rod. Meaning one end you can see, the other end you can't see, it goes to infinity. In this case, the formula will be k lambda by d this way and k lambda by d this way. Have a look at these two. Clear? Next thing. Case 3. What will you do for this case? Let's say you have point P here. Let's say this is 30 and this is 60. Can you tell me what will you take the angles as? Theta 1, theta 2. And if I give you like this is 30 and this is 60. What is theta 1, theta 2? Here, what is theta 1? So theta 1 is the angle with the upper point to the perpendicular. So theta 1 is 60. What is theta 2? Minus 30. Be careful. Because in the derivation, what did you do? Because the theta 2 is going downward, you have taken in the limits minus sign. Means if theta 2 is upward, you would have taken plus theta 2, the signs would have adjusted accordingly. So in this case, theta 1 is 60 and theta 2 is plus 30. Just be careful with this one. So theta 1, theta 2 should be down and theta 1 should be up. But if both are up, then theta 2 will be negative. Clear? Hope everyone copied the formula. Let's see some problems. All copied this? Let's say we have 3 infinite line charges. Plus lambda, plus lambda, plus lambda. This is along x-axis, y-axis, z-axis, and there's a point P here, which is d comma 0. So 3 infinite line charges along x, y, z. Find the field at point P. Infinite line का formula क्या था? 2k lambda by d. There will be no parallel component. There will be only perpendicular component. Along x, y, z axis. Find the electric field at point P. Try. What is the answer for this? Any answers? Next thing. Let's see how to do this. See, for us to understand what I'll do, let this x thing be green line, okay? So from here, this is the perpendicular distance, agreed? How much will that be? 2k lambda by d. Let this thing be in the red direction. So this also is perpendicular. So ये कितना होगा? This is also 2k lambda by d. For the z-axis, ये अलग है. This is catch. What is the perpendicular distance? This is the perpendicular distance, now. It is not d. कितना the perpendicular distance? 2k lambda by d root 2, na? Make sense? For x and y axis, perpendicular distance is d, but for z axis, it is d root 2. And what is the angle between them? 45 and 45. So if you see from the top view, this is how it looks. 2k lambda by d, 2k lambda by d, 2k lambda by d root 2. So resultant will be in this direction, which is 2k lambda by d root 2 plus 2k lambda by d root 2, because I square plus j square, no, magnitude. So just add this up. What will you get? K lambda by d Root 2 plus 2 root 2. That's your answer. Clear? You want it in vector form, I cap plus j cap by root 2 unit vector. That's a unit vector, right? So if I take this point as O to C, that is the direction. OC bar will be I cap plus j cap. OC cap will be I plus j by the magnitude. Have a look at this. That will be actually 3 root 2, no? This will be 3 root 2, yeah. 3k lambda by d I plus j. Please check. Any doubts on this? What we did? So the main catch is z-axis scale perpendicular distance will be d root 2. It's not d anymore. Clear? Next one. Next one. We have an infinite line charge. Is along y-axis. Lambda is something like 10 power minus 3 coulombs per meter. Find the electric field magnitude at the point 1, 2, 3. We have an infinite line charge along y-axis. Find the electric field at 1, 2, 3. Try this. It's a good one. Forgot, yeah? Tell me one thing. For the formula, E is equal to 2k lambda by d. What is d here? What is d? Perpendicular distance from the charge, right? It's a perpendicular distance from the line. How to find perpendicular distance from the line?
Mod
We did
AX
this.
B by 1 plus C upon 0.
So this thing how we did, I taught you this in rotation and I told you to remember this. Remember this question? How to find perpendicular distance from a line? If you want perpendicular distance from y-axis, ignore the y coordinate, right? याद आया moment of inertia में क्या था भाई? So here you want the perpendicular distance from y-axis. So perpendicular distance from y-axis will be, leave the y coordinate, root over x square plus z square, which will be root 10. Done. So 2, k ka value is 9 into 10 power 9, lambda ka value is 10 power minus 3, and d ka value is root 10. That's your answer. So that is the thing, perpendicular distance. Clear? Easy. So don't forget that most people, what they do now, they find the total distance, root over 1 square, 2 square, 3 square. That will be the distance from the origin. You're not interested in the distance. What you want is a perpendicular distance. Next one. Amu cams on, Jaini cams on, Ritam. Abeksha, your cam is still blank, right? You need to do something about it, Abeksha. Every class is the same story. Next one. We have a infinite line charges like this. Lambda, and lambda basically it is bent at the origin. There is a point here, D comma D. Find the electric field at point A. We are just playing with that one formula paper. So we have an infinite line charge. One is plus axis, this is infinity. It is going to infinity along positive x-axis and positive y-axis. It is bent at the origin. Find the electric field at point A. How do you do this? See, how to do this thing. Like I said, remember, you have to define your theta 1, theta 2 properly. This is the point A. First of all, get the angles right. Huh? This is your perpendicular distance. Right? This angle is 90 and this angle is 45. Agreed? So who is theta 1 and who is theta 2? So you can take anyone as theta 1. So I will say this one is theta 1 and this one is theta 2. Choose anything you choose. Chalega. So this component will be how much? K lambda by D sine theta 1 plus sine theta 2. Sine 90, sine 45. The parallel component should be in the direction of theta 1. So if you have taken this as theta 1, it would have been this way. Are you getting it? So it depends on how you are choosing theta 1. So this will be K lambda by D cos 90 minus cos 45 upward. Actually, the signs will take care of it. The other guy, this is point A. So this is 45 and this is 90. So let's say this is theta 2 and this is theta 1. So this component will be K lambda by D sine 45 plus sine 90. The other component will be in the direction of theta 1. K lambda by D cos 45 minus cos 90. I hope you are getting the meaning of this. So it is important you need to define your theta 1, theta 2. So you have to put it in that direction. That's a better way of remembering the formula rather than I cap, J cap. That will be confusing. So if I try to put all of them, I will get sine 90 is 1, sine 45. So K lambda by D 1 plus 1 by root 2. Vertical component will be k lambda by d, that is 0 minus 1 by root 2. Actually वो negative था, मतलब it is downward ना, the sign will take care of it. You don't get confused like किस direction लेना है, you just stick to the convention. And the other vertical component will be, this guy will be k lambda by d 1 by root 2 plus 1, and this will be k lambda by d 1 by root 2 minus 0. These are the components, just add them. So this plus this, so your final answer will be k lambda by d, k lambda by d. So resultant will be 2 root 2 k lambda by d. Clear? Please check your steps. Any doubts on this, please ask me. So they can give you any kind of finite rods and you can use this formula and finish it. Clear? Next one. Can I turn the page? Any doubts? Next one. Arc. What if you have an arc like this? Lambda and radius r, this entire thing is positive charge. Result is more important. This is angle theta. O is the center. Find the field and potential at the center. Try. I'll give you 2-3 minutes. Potential is easy. It is a scalar quantity. You can directly just do KQ by R. Field is interesting. Try. How do you do this? How to integrate? वो तो obvious है. See. How do you choose an element? Whenever you integrate vectors, now be careful. You can't integrate a vector directly. You have to always divide into I cap, j cap, and integrate. So at an angle alpha here, take a thin slice, d alpha. So this charge will be dq, which is lambda into the length rd alpha. Agreed? So this dq charge will give a field E bar in this direction, where this is also alpha. So dE will be k dq by r square, point charge. So k lambda r d alpha by r square. So when you divide into vector components, this will be minus dE cos alpha I cap minus dE sin alpha j cap. Now alpha ka value is going from where to where? Center mein alpha is 0. On the right hand side, alpha is plus theta by 2 because half angle total is theta. Left hand side alpha is minus theta by 2. So now if you integrate this center pe, minus integral dE will be k lambda by r cos alpha d alpha I cap minus integral k lambda by r sin alpha. So integration actually, if you see, is not bad. Getting till here is a problem. Choosing an element is the pain. Once you can choose an element, the integration is quite easy. Limits will go from minus theta by 2 to theta by 2, minus theta by 2 plus theta by 2. Logically speaking, can you see there's a symmetry? Iska bhi d aayega na? So means all the I components will cancel. Only the j component will be left out. So when you actually integrate this stuff, you will end up with minus k lambda by r. This will be sin alpha limits minus theta by 2 to theta by 2 I cap minus k lambda by r cos alpha theta by 2 to minus theta by 2. I goofed up somewhere. ये sin alpha था, ये cos alpha था. J cap. This term will become 0. This whole term is 0. Cos theta by 2 minus cos theta will be 0. So we end up with k lambda by r 2 times sin theta by 2 minus j cap. Now let me put it down. This is the main important thing. The result, like I said. So if you have an arc, if it is plus, then angle theta, lambda and r. At this point, the field will be along the bisector, which is given by 2k lambda by r sin theta by 2. What about the potential? Potential is easy. K, total charge is lambda r theta by r, kq by r. So k lambda theta. If theta becomes equal to pi, means you get a semicircle. This they can ask in the exam. Huh? Find the field due to a semicircle. Lambda and r. So meaning if you put the theta is equal to 180 there, field will be 2k lambda by r. Good result. It looks like infinite wire ka result 2k lambda by d jaisa. It looks like that. 2k lambda by d tha, yahan pe 2k lambda by r tha. Please have a look at this thing. See how I integrated the steps. Easy. Can put on these results. This is for positive charge, okay? Negative के लिए reverse होगा direction. Gravitation में the formula will be 2g lambda by r, but it will be upward because gravitation is always negative charge. Gravitation is always attractive. The results are more important. This could be a direct mains question. The semicircle. Yeah. If you're having dinner, just leave me a message and switch it off for 10-15 minutes. But then switch it back again. Clear with this? Any doubts on this? Someone wants to try as a homework? You can give this a try. Suppose you have a semicircle, lambda is equal to lambda not sine theta. Lambda constant nahi hai. Means the entire ring is having a variable charge. Find the field and potential at the center. So exact same question, क्या change होगा? This lambda will become lambda not sine theta, lambda not sine theta, right? That will change in the integration. Everything else will be same. The steps, elements, choosing, everything same होगा. So if integration में you will get sine square theta का integration, sine theta cos theta का integration. That will be homework. You can give it a try. All got this? Next one. Field on an axial line. Derivation is okay. Now important nahi hai. So if you have a ring like this, and if this is an axial line here, let's say this charge is q and radius r, and let this distance be x. The field at this point E will be k q x by r square plus x square whole power 3 by 2. The potential at that point will be k q by root over r square plus x square. Important results. If you try to plot the graph of this E versus x graph, at the center the field is 0, at infinity the field is 0. The graph looks like this. The maximum value occurs at r by root 2 and minus r by root 2. Please note it down. Gravitation, the formula is gm x by r square plus x squared by 3 by 2. K becomes g and q becomes m. Like I'm saying, everything that we did in electro, you can do everything in gravity. But what you did in gravity, right? No, reverse. Whatever you did in gravity, you can do in electro. Everything in electro, you can't do in gravitation. Because gravitational repulsion is not there. Put on the formulas. Let's see some questions based on this. Derivation is important. Nahi hai. You can try if you want to. Take a small piece dq and you just take the horizontal component. So dE will be k dq by r square plus x square. And you take this horizontal component theta and finish it off. Right, and then you get it from there. It's not a big important derivation. Okay, let's see how to use this part. So let's say what was the last question number? 20. Let's say we have two rings here. This thing has a charge q, radius r. This thing has a charge 4q and radius is 2r. Okay, then distance between them pretty big actually. Okay, let's make it 2r. Let's keep it simple. Let's say this point is A and let's this point be B. Okay. find the field at the midpoint. Just formula substitution. And find the potential at A and B. B is a good one. Let's get this. Just leave it there, don't simplify it. It's just formula substitution. See the first one. So we are talking about this point, right? So let's take this thing as a red thing. So this will be E1. So E1, the formula is K, Q, distance is R by R square plus R square whole power 3 by 2. Agreed? That's the formula, na? K, Q, X by R square plus this thing. If I take this guy to be the green one here, this will push with this way, E2. So E2 will be K, charge is 4Q, distance is R, X by radius will be 2R whole square plus R square whole power 3 by 2. Easy? That's it. Subtracting will get the answer. Yeah, numbers are bad, but okay. How to find the potential? Potential is important. Now see, be careful here. Listen. Let's take this thing as green, red guy, and that thing as green. Most people, what they do now, this is the common mistake they do. When I say potential at A, we are having two potentials, one due to your own ring and due to the other ring also, no? So we have to take this distance due to the other ring also. So VA will be K Q by R due to the same ring, plus due to the other ring will be K, charge is 4Q, and this distance will be root over 2R whole square plus 2R whole square. That is a potential at A. Similarly, what is the potential at B? Potential at B due to the red guy will be K Q by the distance will be root over R square plus 2R whole square plus due to the green guy that will be the own ring, so K 4Q by 2R. Please check this thing. So when you take the potential at the center of the ring, don't forget you have to take due to your own ring and you have to take due to the other ring. Potential is a scalar quantity, it always adds up. This is one mistake people do. When I say potential at A, they just calculate due to this guy. They forget about the other ring. Please have a look at this.
Due to its own rings, a normal formula you can use.
You can use. ये भी कुछ बड़ा formula नहीं है. If you look at this, all points are equidistant. So I'm just using KQ by this distance. Hypotenuse. All clear with this? Just formula substitution. There's nothing there. Next one. Any doubts, please ask me. Let's say a good question based on this. Anyone didn't get any particular part, please ask me. All clear with this? Labdi, Anamai, Ritam, Nishita, Nanya, clear? Let's see how will you do this one. Let's say you have charge plus Q, radius R. There's a point A here, there's a point B here. You're projecting a charge of mass M and plus Q with speed U. Find the minimum speed to reach B. Find U minimum so that the particle reach B on the other side. This is positive, this is also positive. So both will repel, it will slow down. So if you don't give enough speed, what will happen? It will go like this and come back. To find the minimum speed given to the reach B. I told you this many times. Whenever someone says find the minimum, maximum, conservation of energy, conservations. Try. I'll give you a minute. It's a good one, 2 minutes.
So that ring is fixed now.
Ring is fixed. How do we do this? What is the catch? Can someone tell me what is the initial state and the final state?
And
I'll tell you a story. See. Whenever, right, we launch a rocket from Earth to Moon. So this is the Earth, this is the Moon. What happens now? Initially, let's say you're sending some astronauts to Earth to Moon. Initially, rocket is like this. The rocket ka thrusters, right, are like this. The rocket goes. At some point, they reverse the rocket. And then they go slow down, and land. Can someone tell me why do we need to reverse the rocket?
slow down the speed.
Rishi, what do you think? Why do we need to reverse the rocket?
There are no brakes on the rocket, so it's reversible.
Something else? Any other reason?
Its speed is too much. It
वो तो
won't
है.
land.
That is there. What else?
The landing gear is on the bottom.
Point ये है, basically see, at some point the earth ka force and moon ka force become equal, right? So if you can somehow send till here, after this what will happen? The moon will automatically drag the rocket towards the moon. Are you getting it? So if you want to send something to the moon, do you really need to send till here? If you can just send it till the null point, after that automatically it goes, right? So in our question also, observe this clearly. Once you cross the center, if you go this side, what will happen to the charge? It will get repelled, right? So automatically chala jayega na. There's no need to do anything. So you need to push the charge till which point? Till the center, isn't it? If you can push the charge till the center, after that automatically it will get pushed away. There is no need to provide energy till B. If someone has done the question, assuming this is state 1 and state 2, you will get velocity as imaginary. This is, what is this? I'll tell you what is happening. In chemistry, we see this thing. The reactants are here, products are here. Even though the products are more stable, reactants are less stable. Why doesn't the reaction happen automatically? Anyone remembers? If you see, right, burning a paper into carbon dioxide and ash is more stable than paper, then why doesn't all the papers just burn automatically?
It requires activation energy.
You require something called an activation energy. So once you provide enough activation energy, then the reaction will proceed. Same way here, what is happening now? To go from here to here, you need activation energy. After that, automatically it goes off. So that is the statement in this question here. If the charge reaches the center of the ring, basically that is a null point. After that, the charge automatically gets repelled till B. You need not put any effort. Are you getting this? So now tell me again, who is your state 1 and who is your state 2?
State 1 is A, state 2 is the center.
So this is your state 1 point A and state 2 is your center. So speed U. So what is the kinetic energy? Half mu square. What is the potential energy? The potential kq by this distance root over r square plus r square. Did I give the distance? Shit, I didn't give the distance. How did you guys do this? I need to give the distance. So kq by r square into the charge q. State 2, kinetic energy, you just come to rest. Potential energy is not 0, field is 0. Be careful. kq by r into small q. Done. Energy in state 1 is equal to energy in state 2. Half mu square kqqq by root 2r is equal to kqqq by r. You get u from here. Check the answer. So this question is important in that way. Most people will do that mistake. But suppose the same question, if it had been like this, if this was a minus q charge, now can you tell me what will be the answer? Now what to do? What is your state 1 and state 2?
State 1 is like the center and state 2 is B.
You can actually take this is state 1, this is state 2. Because see now, once you cross the center, after going this side, you're still getting pulled backward, isn't it? You have to put effort to cross the center and go. So actually B will be the state 2 then. So be careful with this case. So anyway, Shaurya, doesn't matter. You can take this also as state 1, but anyway, AB equal, hai na?
Okay.
All clear with this question?
Sir, one doubt.
Hmm.
If the charge was minus q, and if they've
Hmm.
specified the electric field that it starts here, ends here, then the right endpoint of the electric field would be state 2, right?
Right end of electric field, matlab?
Like if they have given
Electric fields don't end like that, right? If
no,
you
but if
say
the,
it's
okay.
ending, so yes, then that is the case. Okay. All clear with this? There. We'll just take a small break. Someone is just hitting the door. Right? We'll just take a small break. We'll catch up at 10 o'clock. You can switch off your camera, just be online. We'll start by 10 o'clock again. We'll just take a 5-minute break. Yeah, let's start off. No, I didn't have my dinner actually. I was very hungry. And after the class, anyway, you guys will ask doubts till 11:30. And I'll just finish off little. Yeah, today food got late actually. So let's start off. You guys too can eat and listen. I can't eat and teach them. Anyways, so this was one. Now we have a very good result on this. See, this is another standard result which you can remember. So if you have a charged disk, sigma and radius r, sigma is charged per unit area. This is also called a surface charge density. So if you have at a distance d, at this point P, the field is given by it's a big integration, but the result is more important. Sigma by 2 epsilon 1 minus 1 by root over r square plus d square. Yeah, not that difficult to remember. Now this result, right? If you make something, if you make r tends to infinity, means if you make the radius of the sheet very big, then what will happen? The disk actually becomes a infinite sheet. If r tends to infinity, the disk becomes an infinite sheet. And this term 1 by root over r square plus d square will tend to 0. You get a pretty interesting result. You get a field is equal to sigma by 2 epsilon, which is constant. Means if you have an infinite sheet, no matter how far you go, the field will be always constant, sigma by 2 epsilon. Check this out. This is a disk. The previous thing was a ring. This was a disk result. And this is the result due to a sheet. Clear? Next thing. Let's try this thing. Let's say we have a sector. Sigma and radius r. This entire thing is positive charged. This O is the center. Just find the potential at the center. This is a good one. From there, I'll show you something else. Let's try this. How do you find the potential center due to the sector? It is like a pizza ka slice. Try, give it a try. It's a good one. Just give it a try. Yeah, let's see. Something went bad. I think this food na. I messed up today. Okay, let's see how to do this. Anyone got an answer? No. See. So at a distance x, take a small ring. This angle is theta. Let this thickness be dx. And this length will be x theta. So the charge on that ring arc will be sigma into area. What is the area? The length into thickness. Agreed? Now, due to this arc, what will be the potential at the center? Since all are equidistant, the potential due to the arc will be k q by x, which is k sigma x theta dx by x. X cancels off. So this is k sigma theta dx. This is the potential due to the arc. So if you want the potential due to the sector at the center, integrate all the potential due to the arcs. K sigma theta, all this is constant, only dx is variable. X is going from 0 to r. K sigma theta r. That's it. Check. K sigma theta r. This is the potential due to a sector at its center. So the main idea is how to take an element. If you can take arcs at a distant x, so all these are same distance, the potential will be easy. Field is still tough, potential is easy. Please check. All clear with this? Any doubts how I did this? Clear, na? Hasni, clear? Anamai, Reina, Brinda, Trisha. Now, the actual question is this. We got a disk, sigma, radius r, uniformly charged. A is the point on the circumference. Find the potential at point A. This is an Erdo question. Find the potential at point A. Let's get this. How do you do this? Any ideas how to approach this? See, listen, this idea is important. So from here, what we do now, we take a thin sector like this. We take a very thin sector like this. from angle theta, take a small theta d theta here. So here theta will be 0. If you rotate like this, eventually, right, you will become like a straight line here. Theta will be 90. On the other side, theta will be minus 90. So when theta goes from minus 90 to plus 90, you cover all the sectors, right? This sector, this sector, this sector, like this full sector will be covered. Now, so for this small sector that we have, just now we derived the formula. What is the potential due to a sector? K sigma theta r. The potential due to a sector is K sigma theta r. So here it will be, angle will be d theta into r. Small r is this length. So this is small r. This is capital R, and this is capital R, and this is theta. So if you drop a perpendicular like this, we get small r will be 2r cos theta. That's the relation. So the potential due to the sector will be K sigma d theta 2r cos theta. So potential at point A will be integrate all this stuff 2r K sigma cos theta d theta. Limits will go from minus 90 to plus 90. 2r K is 1 by 4 pi epsilon sigma cos theta, that will become sin theta. Limits will be from minus 90 to plus 90, that will become 2 sigma r by pi epsilon. That's your answer. Check. So the main thing is you should know the result for the sector. Then it looks easy. Or this is a two-step problem. First find for the sector and find for this. This is a proper advanced question. Put it up.
So could you go to the previous slide 1 minute? Okay, sir.
Yeah. Next one. Can I tell the page? Next one. This is a good one. Let's say we have a square plate. Fully charged. We have a cube. Uniformly charged. So if I take this point to be O, and if the corner is A, the center is O, and the corner is A, find VO by VA. Find VA by VO ka ratio. Potential basically. We don't want the exact values, we just want the ratio. If you have a square plate, find the ratio of potential between the center and the corner for a cube center and the corner. How do you approach this? Let's see. See, listen carefully. First of all, when you take the square plate, see, we can find about the center, okay? Center is symmetrical, everyone agrees? So the potential at the center is proportional to the charge of the square plate by the side of the square plate. What is that constant? I don't know. I don't know the proportional constant, but I'm sure about this thing, right? KQ by R, na? Charge by length. Everyone agrees? And for a square plate, charge is proportional to what? Charge is sigma into area. So that means this guy will be proportional to length L, no? Means if you take a square plate of side L, let us take a square plate of side 2L, that 2L will have double the potential. Everyone agrees? So that means if I take a bigger square plate of side 2L, so center mein, if you take here the potential to be V, so let VO be V, how much will this be? 2V, right? And this can be split into 4 parts, isn't it? This can be split into 4 parts. So for each part, this is the point A. So due to the 4 parts, if the potential is 2V, what is the potential due to one each piece? So VA will be 1/4 of 2V naught, agreed? So VA by V naught is half, na? Is this making sense, everyone? Again, look at the logic. For a small square plate, if the potential is V naught, for the big square plate, the potential will be 2V naught. But this 2V naught is given by 4 small square plates. And for the small square plates, A is the corner. For the big plate, A is the center. So if the total is 2V naught, then each plate will give only 1/4 of 2V naught. Is this clear? So you can't calculate the exact values, but you can get the ratio.
So means that center is divided into all 4
4
corners.
ones. Yeah.
Okay.
How to do for the cube? Cube also same, no? For a cube, the potential at the center is again proportional to Q by L. This is always true, but Q will be density into L cube. So this will be proportional to L square. So if you take a bigger cube, so at the center, if you take V for the big cube, what will be the potential? 4V, na? Now you tell me this big cube is made of how many small cubes? The big cube is made of 8 small cubes, na? Agreed? And the point is A here. So that means VA will be 1/8 of the 4V. So that is also V by 2. Answer will be same, people. V naught by V naught is half. So for a square plate and for this cube, दोनों same ही आ रहा है answer. Easy, got this? Next one. Hmm. Clear. Great. Next thing, one more result. Like there are some results which I'm giving you. Actually, these are big derivations. So we are skipping those big ones. Look at these things. So this is another important result. Suppose if you have a part of a sphere. It's not a full sphere, it's a part of a sphere. This is the center. And if you take this angle to be theta, and this is having charge. Okay. So due to this, the field at the center is given by sigma by 8 epsilon 1 minus cos 2 theta. This question was asked in the exam. If theta is equal to pi, you get a hemisphere. This is a hollow shell, part of a hollow shell. So this result will be, just need to put theta is equal to 2 pi. Result will be sigma by 4 epsilon. Both important result. This came in the exam directly. Find the field due to a hollow shell at the center. Please put it up. Clear? Suppose same thing, if you are given in terms of charge, na, sigma, so charge on this guy will be q by 2 pi r square will be sigma. If I just substitute there, I end up with q by 2 pi r square epsilon into 4. That would be kq by 2r. Because 1 by 4 pi epsilon is k. So you can write like that also. That is also an interesting result. Kq by 2r. Both are same. You want to write in terms of charge or you want to write in terms of sigma? This will be more easy to remember, I suppose, kq by 2r. You see which one you like. Clear? Now we have some results, okay? Hollow sphere and solid sphere. We will write down the results today. Tomorrow we'll be doing questions on those. So hollow sphere and solid sphere results are the quite important one. We don't have the derivations in this. We'll do it in Gauss law. But whenever they ask questions in mains, now, especially electrostatics and gravitation, they ask questions on hollow and solid sphere half the time. So charged hollow sphere. So if you have a sphere uniformly charged, the field is 0 for r less than r, meaning that inside the entire field is 0. No matter where you stand, it is 0. You know what is the meaning of that? Imagine if Earth was actually a hollow sphere, right? If you make a hole and if you jump inside you will just literally keep floating. There's no gravity. And outside, it behaves as if it is like a point charge. Now, why is this happening? I'll give an example, logic, see, reason why it is happening. Let's say you choose any one random point here, okay? And from here, if you look at this angles here, this angle are equal, agreed? Angles are equal. Now, you agree, this is a small area, right? Let's say this area is, let's say this distance is R1. This area is A1. This A1 will be K into some R1 square, agreed? K is some constant, jo bhi hai. Similarly, if you look at this distance, this is R2. This area will be A2, which is K into R2 square. Now, if you look at the field ka formula, field is equal to K Q by R square. And we know Q is equal to sigma into area. So this will become E is equal to K. And this is sigma, area will be K into R square by R square. Can you see what happened? R square got cancelled. That means whatever field the E1 is generating, the E1 ka field and E2 ka field, they'll always cancel out. If you see here, E is proportional to Q by R square. This is proportional to area by R square. This is proportional to R square by R square. Means E ka value is same for any piece. Is this making sense? Or if you're confused, I'll just write it down. So when you're at E1, E1 will be, let's take this constant as something else. So A1 is proportional to, let's say some constant CR square. CR2 square. So E1 will be K sigma C R1 square by R1 square. R1 square cancel ho gaya dekho. K sigma C. E2 will be K sigma C R2 square by R2 square. R2 square cancel ho gaya. K sigma C. E1 is equal to E2. They'll always cancel. Therefore, field at any point is 0. So this happens only for a sphere. Huh? Sphere is special. Clear with this? So this is how you can prove that. But like I said, the result is more important. And if you try to plot the graphs, E versus R, so initially the field is 0 and then it discontinuity and decreases. If you look at the potential is KQ by capital R. Outside it behaves like a point charge. So outside is always easy, right? Outside it always behaves like a point charge. If you try to plot this graph, B versus R, I think you should note down this actually. Put it up. Tomorrow we'll be doing questions based on this. This is the hollow spherical results, field and potential. Gravitation में K becomes G, Q becomes M with a minus sign because gravitation is always attractive. The formulas are exactly same. Put it up. Copied. There's no discontinuity in second graph. It's a continuous graph, second one. Because see now, when you keep small r is equal to capital R, the values will be same for both. Clear? The next one, solid sphere. So do mug up the results and come tomorrow. the field is given by K Q small r by r cube for r less than equal to r. Outside it behaves like a point charge. The outside is always like a charge at the center. And if you try to plot this field E versus R, it will increase linearly and then drop. Out of all the formulas, this potential formula is the most important one because it's pretty weird. KQ by 2r cube into 3r square minus small r square. Questions have come directly on this formula. And simple reason, most people can't remember this. So make sure to mug up this properly. KQ by r for r greater than equal to r. So if you try to plot V versus R graph, so this will be like this is a parabola and then it will be decay function. Check. These are the two things. So do mug up all this stuff. Make sure to go through all the things you have done. There are a lot of formulas and stuff. We'll do some more variations of this in the tomorrow's class. Okay, so with this, we'll wrap up for the day. So any doubts in today's class, anything you can ask me, I'll also free to leave. So take care, stay safe. I'll see you tomorrow at 9 o'clock.